Imagine for a moment that we just vanished, not in some fiery apocalypse, not with a bang, but quietly. One day, humans are here, bustling around, doing human things, and the next day, poof, it's gone. The buildings are still there, the cars are still parked, but no people. What happens then? The world would keep turning, of course. Plants would grow, animals would roam. And a big question comes up for a lot of people: could another species ever get smart like us? I mean, really smart, build things, talk in complex ways, think about the future, wonder about the stars. It's a huge question, and there's no easy yes or no answer. This isn't a science fiction story, though it feels like one. We're talking about real evolution, the messy, slow, incredible process that brought us here. First, let's get clear on what intelligence we're even talking about, because a lot of animals are smart in their own ways. A squirrel remembers where it buried hundreds of nuts. A spider builds an amazing complex web. A bee can tell its friends where the best flowers are. That's intelligence for sure. But when we ask if another species could evolve intelligence like ours, we usually mean something more specific. We mean abstract thought, self-awareness, complex language that isn't just about immediate needs, cumulative culture where knowledge builds up over generations, tool-making that gets more advanced over time, and the ability to reshape the environment to a massive degree. That's the human kind of intelligence. It's a very particular package of traits. So, how did we even get here? It wasn't a straight line, that's for sure. Our ancestors started walking on two legs millions of years ago. That freed up our hands. Hands are really important. They let us grab things, manipulate them, make tools. And once you start making tools, you get a feedback loop. Better tools need a smarter brain to design them, and a smarter brain can make even better tools. Our brains got bigger, especially the parts that handle planning, problem solving, and language. Living in big social groups probably pushed us to get smarter too. You have to understand what others are thinking, cooperate, sometimes even trick each other. Fire was a game changer. It cooked food, making more energy available for our hungry brains. It gave us light and warmth, protection. It brought us together around a campfire, which helped with language and storytelling. All these things over millions of years stacked up. It was a unique set of circumstances. Now, if we disappear, the world doesn't have a reset button that says, okay, time to make another human-like species. Evolution isn't trying to make us. It's not trying to make anything specific. It just favors whatever traits help a species survive and reproduce right now in this environment. If being slightly dumber but faster helps you survive a predator, then that trait might win out. Intelligence, especially the kind we have, is incredibly expensive. Our brains use a huge amount of energy, something like 20% of our daily calories, even though they're only 2% of our body weight. Growing a big brain takes a long time, meaning our babies are born pretty helpless and need a lot of care for a long time. That's a big trade-off. It only works if the benefits of that intelligence truly outweigh the costs. So, is intelligence inevitable? Probably not. Look at how many species there are on Earth. Most of them are doing just fine without human-level intelligence. Bacteria, insects, fish, birds, most mammals, they have found incredibly successful ways to live, reproduce, and thrive without building cities or writing poetry. Evolution is incredibly good at finding solutions, and most of those solutions don't involve massive brains and abstract thought. It's a possible path, but a very rare one. But let's say the conditions were right. What species might have a shot? Who are the contenders if we're out of the picture? One obvious group is our closest relatives, primates. Think chimpanzees, gorillas, orangutans. They are already smart. They use tools, they can learn from each other, they have complex social lives. Chimps can learn sign language, solve tricky puzzles, and even show empathy. So, they have a good starting point. They have hands, which is a big deal for tool use. But here's the thing. They haven't evolved our kind of intelligence yet, even with millions of years alongside us or before us. Their current level of intelligence seems to be good enough for their niche. They're really successful as they are. For them to make the leap, something fundamental would need to change in their environment or social structure. Maybe new pressures, like drastic climate shifts, would force them to innovate more, to cooperate more, to think more abstractly. But they'd still have to overcome the challenges of bipedalism, not a given for them, a larger brain energy cost, and the specific conditions that led to our unique path. It's possible, but not a sure thing. Then there are the cetaceans, dolphins, and whales. These guys have huge brains, some even bigger than ours. They have complex communication, though we don't fully understand it. They live in social groups. Dolphins show self-awareness, problem solving, and even culture. Different pods have different hunting techniques they teach each other. They're super intelligent in their own way, but they live in the ocean. This is a massive limitation for our kind of intelligence. No hands, no fire, no complex technology. How do you build a wheel underwater? How do you smelt metal? You can't. Their intelligence is adapted for their aquatic world. It's about navigating sound, social bonds, and hunting in a liquid environment. Could their intelligence evolve into something different, something profound, but not tool and tech based? Absolutely. Could it become our kind of intelligence? It's hard to imagine given the physical constraints of their environment. Let's think about corvids, crows, ravens, jays. These birds are incredibly smart. They use tools like bending wire hooks to get food, they remember faces, they can solve multi-step puzzles. They show planning and even understand cause and effect. They have complex social structures and communicate in sophisticated ways. Some even hold funerals for their dead. They're amazing, but again, limitations. They have beaks and claws, not hands. That makes fine manipulation of objects, like crafting intricate tools, very difficult. Their brains, while dense with neurons, are still physically constrained by flight. A giant brain is heavy, and their communication, while smart, isn't built for complex, abstract language in the same way human speech is. Could they get smarter? Yes. Could they build a technological civilization? This, it seems like a very, very long shot. And then there's the incredibly strange and fascinating octopus. These creatures are true marvels of evolution. They have amazing problem-solving skills, can open jars, escape complex mazes, and use camouflage in incredible ways. They can even use tools like carrying coconut halves to use as shelter. They are highly intelligent, but their evolutionary path is so different from ours. Their intelligence is distributed throughout their arms, not just concentrated in one central brain. They are masters of disguise and short-term problem solving, but octopuses have short lifespans, usually just a few years. This makes cumulative culture-passing complex knowledge from one generation to the next incredibly difficult. There's not enough time. They are also mostly solitary. Our kind of intelligence really thrives on social interaction and the sharing of knowledge over many generations. And like dolphins, they are aquatic, which limits technology. So while incredibly smart, they're probably not on the path to becoming human-like intelligent. What about other animals? Elephants have huge brains, complex social structures, amazing memory, and can use their trunks with incredible dexterity, almost like a hand. They show empathy and even mourning rituals. They are definitely intelligent. But their form isn't built for the fine motor skills needed for complex tool-making and manipulation, nor for the specific vocalizations for intricate language like ours. Rats are adaptable, can solve problems, and live everywhere, but their individual brain power doesn't seem to be on the trajectory for abstract thought and complex culture. Canids, like wolves and dogs, are social and intelligent in their own right, but their evolutionary pressures have leaned more towards pack hunting and territorial defense, not the development of advanced technology or language. So, if we look at the candidates, they all have some pieces of the puzzle, but none have the full set of circumstances that pushed humans down our unique path. What are those circumstances, those driving factors, anyway? What truly pushed us to evolve this specific kind of intelligence? One major factor is environmental pressure. Think about our ancestors in Africa. Changing climates, shrinking forests, expanding savannas. They had to adapt. They couldn't just keep doing what they'd always done. New predators, new food sources. This pressure pushed for innovation, for finding new ways to survive. If a species faces new, continuous, and complex problems, and if intelligence helps solve those problems, then evolution might favor it. If the world stays relatively stable for a species, and their current intelligence works fine, there's no strong push to evolve more. Social complexity is another huge one. Humans are incredibly social. Living in large groups means you need to understand social dynamics, track relationships, cooperate for hunting or defense, and even sometimes deceive others. This demands a lot of brain power. The social brain hypothesis suggests that the need to navigate complex social interactions was a major driver for our brain expansion. If a species lives mostly alone or in very simple groups, that pressure isn't there. Then there's tool use and manipulation. As I mentioned, hands are critical. Bipedalism freed up our hands. Once our hands were free, we could start making and using tools. And this created a positive feedback loop. Making a sharp stone tool requires a certain level of planning and dexterity. Using that tool to hunt or process food provides better nutrition, which can support a larger, more energy-hungry brain. That smarter brain can then conceive of even better tools, and so on. Without hands, or something equivalent like an elephant's trunk or an octopus's arms, the path to tool-based technology is very limited. But even with a trunk or arms, the sheer dexterity of a human hand is quite special. The language and communication are also crucial, not just simple calls, but complex, symbolic language. The ability to share abstract ideas, to plan together, to teach complex skills, to pass on knowledge from one generation to the next in a detailed way. This is what allows for cumulative culture. Each generation doesn't have to start from scratch. They can build on what the previous generation learned. Without this, even if individuals are smart, the species as a whole won't make much progress in terms of technology or complex knowledge. Think about it, if every time an inventor died, their inventions died with them because no one could explain them well enough, we wouldn't be very advanced. And we can't forget fire. This was a monumental step for humans. Cooking food made it easier to digest, meaning we got more calories from less effort. That extra energy fueled our big brains. Fire also provided warmth, protection from predators at night, and light to extend our active hours. It became a central gathering point, fostering social bonds and communication. Imagine trying to get a technological civilization off the ground without fire. It's incredibly difficult to process raw materials, to smelt metals, to create ceramics. For an aquatic species, or one without the means to control fire, this hurdle is enormous, perhaps insurmountable for a human-like technological path. Curiosity and play might seem minor, but they're actually important too. Learning for the sake of learning, experimenting, just seeing what happens. That kind of behavior, often seen in intelligent species when they're young, allows for discovery and innovation that isn't always tied to immediate survival needs. It's part of how we push boundaries. And finally, time. Evolution is agonizingly slow. It took millions and millions of years for humans to get to this point. Even if another species started down a similar path, it would likely take a similarly vast amount of time. The conditions have to persist for those millions of years. So given all these factors, why is our kind of intelligence so rare? What are the obstacles? The energy cost is a huge one, as mentioned. A big brain is a hungry brain. A species needs a consistent, high-calorie food source to support it. If food is scarce or unpredictable, evolution will favor a smaller, more efficient brain. Then there's the long gestation and child-rearing period. Our babies are born very helpless and need years of care and teaching. This means parents, and often the wider social group, need to invest a massive amount of resources and time. This only works if the group is stable, cooperative, and the benefits of those intelligent offspring eventually pay off. If predators are abundant or food is too scarce, raising such vulnerable, dependent young becomes a huge liability. And the flip side of a big brain is that it makes birth difficult. Human childbirth is dangerous largely because of our big heads. This is another evolutionary bottleneck that species would have to overcome. Many species also fall into what you could call evolutionary traps. They find a perfectly good way to survive and thrive without evolving advanced intelligence. Why would they change? If being a fast runner, or having sharp claws, or being able to blend into the background, or reproducing in huge numbers works, there's no pressure for a species to suddenly become a deep thinker. Evolution is about good enough, not best, or most advanced. The lack of specific niche pressure is key. If the existing level of intelligence and physical adaptations allows a species to dominate its niche, there's no reason for further, costly intelligence to evolve. Our ancestors were in a unique position where existing solutions weren't quite cutting it, and intelligence offered a new path. Some people even talk about a great filter, an idea from space exploration that suggests there might be some extremely hard steps in the evolution of life or intelligence, so hard that very few species ever make it past them. For us, maybe evolving our specific package of intelligence was one of those filters. The conditions needed to get there were so particular, so many stars had to align, that it just doesn't happen very often. But what if intelligence isn't just one thing? We define it based on our experience. What if another species evolved a completely different kind of intelligence? Not one focused on technology and manipulating the environment, but something else entirely. Imagine an intelligence that is deeply spiritual or philosophical without any need for tools. Or an intelligence centered entirely on understanding complex biological systems or weather patterns, a profound connection to the natural world. Could there be a form of consciousness that doesn't rely on individual brains, but on a collective, like a highly evolved superorganism or a plant network? That would be a different beast, not quite what we mean by individual species intelligence, but it would still be a form of profound cognitive ability. Or what if intelligence wasn't about controlling the environment, but understanding it so deeply that you live in perfect harmony with it without leaving a trace? That wouldn't build cities or spacecraft, but it would be a very sophisticated way of existing. We tend to value intelligence that can change the world because that's what we did. But maybe that's just one path. The short answer is yes, it's possible. Evolution is incredibly creative, and given enough time, almost anything could happen. Life has a way of finding new solutions. If humans disappeared, the ecological slate would be wiped clean of our dominant influence. New niches would open up. Resources would become available. The pressures and opportunities that exist would be completely different. But no, it's not guaranteed, and it's certainly not likely to happen quickly. The conditions that led to human intelligence were a very specific, rare, and lucky combination of circumstances, environmental pressures, social needs, the evolution of hands, the harnessing of fire, the development of complex language, and a huge amount of time. If another species were to go down a similar path, it would need a similar confluence of events. It would need to overcome the massive energy costs of a big brain. It would need to develop hands or very dexterous manipulators. It would need to harness something like fire. It would need to evolve complex, abstract language and social structures that support cumulative culture. And it would need millions of years for all these pieces to fall into place, for evolution to slowly, painfully, step by step, build something new. The Earth would be fine without us. Life would continue. New species would evolve. Old ones would adapt. Perhaps, one day, in the deep future, millions of years from now, some distant descendant of a crow, or a chimpanzee, or an octopus, might find itself facing the right pressures and opportunities to start down a path towards something we might recognize as intelligence. They might look at our abandoned cities and wonder about the strange, short-lived creatures who once built them. Or, perhaps, life would simply continue in its myriad forms, intelligent in its own ways, without ever feeling the need to build a rocket or write a novel. It's a beautiful thought either way. The universe doesn't have a quota for intelligent species. Since we happened, maybe someone else will too, or maybe we were just a fluke, a brief, fascinating flicker in the long, long story of life on Earth.